Hello students, welcome to first PUC physics class, and today we'll continue that third chapter of first PUC physics, that is motion in a straight line. In last class we discussed about these uses or applications of velocity time graph, and today we'll continue that one of the applications using velocity time graph we can derive equation of motions. First we'll see what is equation of motions. It is an equations which is giving a relations between different physical quantities like v naught initial velocity, v final velocity of moving body, a is acceleration of a body, and t is the time taken, and x displacement. Using these equations, we can get relations between these physical quantities. What are that equations? First one is v is equal to v naught plus at, x is equal to displacement x is equal to v naught t plus half at square. Third is v square is equal to v naught square plus 2ax. And fourth one is xn. Xn is distance traveled in a nth second, nth time interval. And that is xn is equal to v naught plus a by 2 to n minus 1. Okay. And these are called equation of motion. And this equation of motions, how we can derive using velocity time graph. That is where derive these equations of motion. That is v is equal to v naught plus at using velocity time graph for a body which is uniformly accelerating. Consider a body which is uniformly accelerating for a time t seconds. It starts with the initial velocity v naught, and after the t seconds its final velocity into v. Then we will draw a velocity time graph for this particular body which is uniformly accelerated. Okay. Let us see how we know that how to draw velocity time graph. By taking this velocity along y-axis and time along x-axis, we will plot a graph, and that graph is represent for a body which is uniformly accelerated is always a straight line, and see that here also it starts with the initial velocity v naught at a, and will draw a straight line, and by that it at a, after a time t seconds at point b, by that it is straight line inclined with the time axis. Shows that body is uniformly accelerated. Body uniform acceleration ಕಾರಣ ಅದು straight line ಆಗಿರುತ್ತೆ and inclined with a time axis. Now this velocity time graph, what is OA is represent initial velocity, and dB is represent final velocity, and OD is represent time. And using this velocity time graph for a body which is uniformly accelerated, now let us see how to derive these equations. We know that acceleration of moving body for a body which is uniformly accelerated is always equal to slope of velocity time graph. Correct? In the application of already study ಮಾಡಿದರೆ, the slope of velocity time graph is always giving acceleration. Based on this concept, ಇಲ್ಲಿ acceleration ಅಂದರೆ equal to slope. The slope ಅನ್ನು ಹೇಗೆ find out ಮಾಡೋದು? We will draw a triangle for this particular velocity time graph for a AB. We draw a triangle. At any position you can draw a triangle. That will get a triangle ABC to find out the slope of this particular line, and there is nothing but ratio of height divided by base. In the height ಅಂದರೆ BC divided by AC, that is giving slope. Therefore slope is equal to BC by AC. You know that in figure AC is equal to OD and BC is equal to V minus V naught. Okay? Again, in this substitution model, then acceleration A is equal to BC, that is V minus V naught divided by AC, that is OD, that is equal to T. Then we get equation A is equal to V minus V naught by T in the equation figure. I will rearrange this equation. T, which is in denominator of right hand side, will take to left hand side. Then we get AP is equal to V minus V naught, or V is equal to V naught plus at. And this is the first equation which is derived using velocity time graph. Now we will derive the second equations. That is an important equation which is asking for 5 marks. Derive equation x is equal to v naught t plus half t square using velocity time graph. Consider a body which is uniformly accelerated. It starts with the initial velocity v naught, that after t seconds its velocity will be v, that is final velocity. ಈಗ ನಾವು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ದಟ್ x is a displacement in a time t seconds. Now using this velocity time graph, how to derive these equations? First we'll draw a velocity time graph. As you know, by taking velocity along y-axis and time along x-axis, we'll plot a graph. Since it is uniformly accelerating, it is a straight line. AB is represent velocity time graph for a body which is uniformly accelerated for a t seconds. Like that in figure, OA is represent its initial velocity v0 and dB is represent its final velocity v and OD is represent its time. Then we know that area under this AB graph line AB, that is a represent always displacement. Okay, that we know in a application of velocity time graph, area under VT graph is giving distance or displacement. Like here x have to find out that below this line AB, or if you calculate area, we will make one triangle ABC, and below one square is rectangle is getting, there is a OACD, and I have to find out total area of triangle plus rectangle, and that is giving displacement. Therefore x is equal to area of rectangle OACD plus area of triangle ABC. We know that how to find out area of rectangle, length into breadth. ಉದ್ದ ಗುಣಿಸಾಗಲ ಸಿಕ್ಕಿದೆ ನಮಗೆ ವಿಸ್ತೀರ್ಣ ಸಿಗುತ್ತೆ. ಅದೇ ರೀತಿ OA into OD is giving area of rectangle plus area of triangle, you know that half into base into height, like that half into base here AC into height BC. Okay. Then AC is equal to OD, like that we will get the next step. The x displacement x is equal to OA, that is V0 into OD is T plus half into again AC is equal to OD, that is T into BC, that is V minus V0. That is our equations we got. Now we have to rearrange this equation. We already know that in a previous derivation we studied, acceleration A is equal to V minus V0 divided by T. Okay. ಅದನ್ನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡುವ. ಬಟ್ V minus V0 I write as a AT ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ. V minus V0 is equal to AT in equation. Then we will get x displacement x is equal to V0 T plus half into T into AT. Then T and T is get T square. Then finally we will get a equation displacement x is equal to V0 T plus half AT square. And this is the second equation which is derived using velocity time graph. I will derive the third equation of motions, that is v square is equal to V0 square plus 2ax using velocity time graph. Now we got ಇನ್ನೊಂದು equation, this is also very important, 5 mark question ಕೇಳ್ತಾರೆ. Derive equation v square is equal to V0 square plus 2ax using velocity time graph. Consider a body is start with the initial velocity V0 and moving with the uniform angulations. After t seconds, it is final velocity is v and displacement is x. Let us draw a velocity time graph for this particular body, and such a way that as in figure, taking velocity along y-axis and time along x-axis, since it is uniformly accelerated, we are getting a straight line, that the line AB is represent velocity time graph for this particular moving body. Now using this velocity time graph, we know that the displacement x is equal to area under graph AB. Area under graph AB and find out model as in previous derivations, how to find the area under by taking area of triangle plus area of rectangle, like that area of triangle ABC plus area of rectangle OACD, that is giving total area of this line AB. Let us find out this area, that is again the x displacement x is equal to OA into OD plus half into AC into BC. That OA, that is V0 into T plus half into T into P minus V0, and that is equation 1. It is still it is a same as that of previous derivation. Now we have to rearrange this equation. That is a x is equal to, now v naught t, I will rewrite like that. I will multiply for this term by 2 divided by 2. The term here, ಎರಡರಿಂದ ಗುಣಿಸಿ ಎರಡರಿಂದ ಭಾಗಿಸುವ, then values does not changes. That will multiply 2 to v naught, then 2 v naught divided by 2 plus, I will split that term into 2. Write this, the next half v t into v naught, v minus v naught, I will write as a v t by 2 minus v naught t by 2. ಅದನ್ನು ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಹೀಗೆ ಬರುತ್ತಾನೆ, vt by 2 minus v naught t by 2. Next I will get equation is like that, 2 v naught t by 2 plus vt by 2 minus v naught t by 2. ಇಲ್ಲಿ ಈಕ್ವೇಷನ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡು ಹೇಗೆಂದರೆ, ಇಲ್ಲಿ v naught t by 2 ಇಲ್ಲಿದೆ, 2 v naught t by 2 ಇದೆ, ಅಲ್ಲಿ ಒಂದು v naught t by 2 ಅನ್ನು ಕ್ಯಾನ್ಸಲ್ ಮಾಡು, ಮೈನಸ್ v naught t by 2 and here plus 2 v naught t by 2, there 1 v naught t by 2 is gets cancelled, then 1 v naught t by 2 is left. After that I will rewrite like this, after cancelling minus v naught t by 2, we will get vt by 2 plus v naught t by 2. I will combine like that. This is a x is equal to v plus v naught into t by 2, and this I will write as a equation 1 ಅಂತ ಬರೀತಾನೆ. Okay, this is equation 1, x is equal to v plus v naught into t divided by 2. And we have another equations which is giving a acceleration a is equal to v minus v naught by t. In a previous derivation we derived this, the acceleration a is equal to v minus v naught divided by t. I will write as equation 2. Now I will multiply both equation 1 and equation 2 ಎರಡನ್ನು multiply ಮಾಡುವ. Then what is the left hand side? It is the x into a will get ax, and right hand side will get like this. This is right, ax is equal to v plus v naught into t divided by 2 into v minus v naught divided by t. ಇಲ್ಲಿ ಕೇರ್ಫುಲ್ ಆಗಿ ನೋಡಬೇಕು, the v plus v naught into t divided by 2, that t is in numerator into v minus v naught divided by t, t is denominator, that 2 t's get cancelled, ಅದು ಎರಡು ಕ್ಯಾನ್ಸಲ್ ಮಾಡು. Then what is that left here, and that is you get that ax is equal to v minus v naught into v plus v naught divided by 2. And this is similar to an equation which is used in maths, a minus b into a plus b in the form that we know that a minus b into a plus b is a square minus b square. This relation we apply we will get a v minus v naught into v plus v naught is b square minus v naught square. These relations will rearrange these equations as ax is equal to v square minus v naught square divided by 2. What is 2 in denominator of right hand side of equation, I will take to left hand side, then it will come to numerator, then get 2ax is equal to v square minus v naught square, and by rearranging this equation we get v square minus v naught square is equal to 2ax, or v square is equal to v naught square plus 2ax. And this equation we derived using velocity time graph. Next we will see acceleration time graph. Okay. Acceleration time graph ಅಂದ್ರೆ ಏನು? Then how to draw acceleration time graph for a moving body. By taking acceleration of a moving body along y-axis and time along x-axis, we will plot a graph, and that graph is called acceleration time graph. ಒಂದು ಬಾಡಿ ಆಕ್ಸಿಲೇಟ್ ಆಗ್ತಾ ಇರಬೇಕು, ಮೂವಿಂಗ್ ಆಗ್ತಾ ಇರಬೇಕಾದ್ರೆ ಅದರ acceleration note ಮಾಡಿಕೊಂಡು for a different time interval we will plot a graph, that is called acceleration time graph. And using this acceleration time graph, the area under acceleration time graph is represent this change in velocity during that particular time interval. The acceleration time graph na area ಏನಿದೆ, ಗ್ರಾಫ್ ನ ಕೆಳಗಡೆ ಇರುವ ಏರಿಯಾ ಅದು change in velocity ಅನ್ನು ಕೊಡುತ್ತೆ. And let us see how acceleration time graph looks for different kind of motions. ಬೇರೆ ಬೇರೆ motion ಇದೆ ಯಾವ ರೀತಿ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Time graph for a body which is moving in a uniform acceleration with a straight line parallel to time axis. Similarly, acceleration time graph for a body which is increasing acceleration, the acceleration increase ಆಗ್ತಾ ಹೋಗುವ ಕಾರಣ is a straight line inclined with the time axis. Similarly, acceleration time graph for a body which is decreasing acceleration ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗಿದ್ರೆ, for example, it is putting a brake for a vehicle, acceleration ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, then acceleration time graph is a, as shown in figure, this decreases with inclined with the y-axis. These are the acceleration time graph for a different type of motions. This topic is acceleration due to gravity. What is meant by acceleration due to gravity? ಗುರುತ್ವಾಕರ್ಷಣ ಶಕ್ತಿಯಿಂದಾಗಿ ಬಾಡಿ ಆಕ್ಸಿಲೇಟ್ ಆಗುತ್ತೆ ಆನ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ಅರ್ತ್, ಅದನ್ನೇ acceleration due to gravity ಅಂತ ಹೇಳ್ತಾರೆ. So what is acceleration due to gravity and how it is varies place to place, etc. We'll see here. See, the force of attraction of earth on a body is called force of gravity ಅಂತ. ಈ ಭೂಮಿಯ ಮೇಲಿರುವ ಎಲ್ಲ ಪ್ರತಿಯೊಂದು ವಸ್ತು ಕೂಡ ಅರ್ತಿನ ಗ್ರಾವಿಟೇಷನ್ ಫೀಲ್ಡಿಂದಾಗಿ ಅದು ಅಟ್ರಾಕ್ಟ್ ಮಾಡುತ್ತೆ, ಅದನ್ನೇ ಫೋರ್ಸ್ ಆಫ್ ಗ್ರಾವಿಟಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಒಂದು ವಸ್ತುವನ್ನು ಮೇಲಿನಿಂದ ಕೆಳಕ್ಕೆ ಬಿಸಾಡಿದಾಗ ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಫಾಲಿಂಗ್ ಗ್ರೌಂಡ್, and that is you familiar about when apple is falling, the neutron is identified. Why it is falling? That is because of gravitation force. It's always falling towards the earth. Acceleration produced by a body due to this force of gravity, ಈ ಫೋರ್ಸ್ ಆಫ್ ಗ್ರಾವಿಟಿ ಇಂದಾಗಿ ಆ ಬಾಡಿಯಲ್ಲಿ ಉಂಟಾಗುವ ಆಕ್ಸಿಲೇಷನ್ ಅನ್ನೇ ಆಕ್ಸಿಲೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಅಂತ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಕ್ಸಿಲೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ. ಇಟ್ ಇಸ್ ಡಿನೋಟೆಡ್ ಬೈ ಎ ಲೆಟರ್ ಸ್ಮಾಲ್ g. ಅದರ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಆಲ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಪರ್ಪಸಸ್ its value is taken as 9.8 meter per second square. Of course, if for a given place it is a constant, from place to place slightly varies, but on an average we are taking as 9.8 meter per second square. Then in the absence of air, for all objects it has experienced the same acceleration under a gravity. All object kuda without considering its size, masses or dimensions, all object kuda ಒಂದೇ ರೀತಿಯಲ್ಲಿ ಆಕ್ಸಿಲೇಟ್ ಆಗ್ತಾ ಕೆಳಗೆ ಬೀಳುತ್ತೆ. For example, here one ball and one feather is there. Ball is heavier and larger in size, feather is lighter, but even whether heavier or lighter, both are falling in a same acceleration. You know, that indicates that acceleration due to gravity is a constant and is a constant for all the bodies. Okay? And these are very important things. Now we'll see how acceleration is taking place due to gravity and for a different cases. Okay? Suppose a body is freely falling, when body is thrown downwards, when body is thrown upwards. ಈಗ ಮೂರು ಕೇಸಲ್ಲಿ acceleration due to gravity values ಅನ್ನು ಹೇಗೆ ತಗೊಳ್ಬೇಕು, then how I attempt for this equation of motions. These are the things we will see here. Say I will drop a one body or ball from a certain height. ನಾನೊಂದು ಬಾಲ್ ಅನ್ನು ಡ್ರಾಪ್ ಮಾಡ್ತೀನಿ, ಕೆಳಗೆ ಬಿಡ್ತೇನೆ, ವಿದೌಟ್ ಗಿವಿಂಗ್ ಎನಿ ವೆಲಾಸಿಟಿ. ಜಸ್ಟ್ ಅದನ್ನು ಕೆಳಗೆ ಬಿಟ್ಟು ಕೆಳಗೆ ಬೀಳುತ್ತೆ. ಅಂಡರ್ ಆಕ್ಸಿಲೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟೇಷನ್ ಫೋರ್ಸಸ್ ಗೆಟ್ ಆಕ್ಸಿಲೇಟೆಡ್, ಅದರ ವೆಲಾಸಿಟಿ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ದೆನ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿಯನ್ನು ಆಗ ನಾವು ಯಾವಾಗಲೂ ಝೀರೋ ಅಂತ ತಗೊಳ್ಬೇಕು. ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ವಿ ನಾಟ್ ಇಸ್ ಝೀರೋ. ನನ್ನ ಬಾಡಿ ಇಸ್ ಫ್ರೀಲಿ ಫಾಲಿಂಗ್ ಅಂತ ಹೇಳಿ, ನನ್ನ ಬಾಡಿ ಇಸ್ ಫ್ರೀಲಿ ಫಾಲಿಂಗ್, initial velocity is 0, v naught is 0, then acceleration is plus g. Again the body is slowly falling downwards, then acceleration also along the same direction. Direction of motion alle adu acceleration kuda agta iruva karana adannu positive ತಗೊಳ್ಳಿ, and value is 9.8 meter per second square. And what happens is equation of motions. The equation of motion ಯಾವ ರೀತಿ ಬರೆಯುವುದು? And first equation, v is equal to v naught. V naught is 0, therefore is a 0, plus a, acceleration a is g here into t, like v is equal to gt. And second equation, see displacement under height to which is falling, therefore x is equal to h will write, h is equal to v naught t. Since v naught is 0, the term is 0, plus half gt square, and third equation, there is a v square is equal to v naught is 0 here, v naught square is 0, v square is equal to 2gh. And these are the equation of motion for a body which is freely falling. Next we will see, suppose body is falling but given certain initial velocity. The initial velocity ಕೊಟ್ಟು ನಾನು ಕೆಳಗೆ ಬಿಸಾಡ್ತೇನೆ. Ball is thrown downwards. What is the equation of motion? Now we are given a certain initial velocity where v naught is not zero, it is non-zero. Then equation of motion is v is equal to v naught plus gt. Second equation, h is equal to v naught t plus half gt square. Third equation is v square is equal to v naught square plus 2gh. These are the equation of motion for a body which is thrown downwards. Next we will see, suppose body is thrown vertically up. ಈಗ ಮೇಲಕ್ಕೆ ಬಿಸಾಡಿದರೆ ಏನಾಗುತ್ತೆ, equation of motion ಹೇಗೆ ಬರೆಯುವುದು for a body which is thrown vertically up. We are given certain initial velocity. ನಾವು ಈಗ initial velocity ಕೊಡ್ತೇವೆ, ಬಟ್ ಆಕ್ಸಿಲರೇಷನ್ ಯಾವತ್ತು ಕೆಳಗಡೆ ಇರುತ್ತೆ, ಬಾಡಿ ಮೇಲಕ್ಕೆ ಬಿಸಾಡುತ್ತೆ, ಆಗ ಅದು ವಿರುದ್ಧ ದಿಕ್ಕಿನಲ್ಲಿದೆ. Then because of that reason acceleration is taken as minus g. Acceleration minus g ತಗೊಳ್ಳು and given a certain initial velocity v naught, and when it reaches a maximum height, ಅದು ಮೇಲಕ್ಕೆ ಹೋದಾಗ ಅದರ final velocity 0 ಆಗುತ್ತೆ. Okay, final velocity is 0, v is 0. And what is the equation of motions? There is a, for a first equation, v is equal to v naught minus gt. Second equation, h is displacement, and displacement is h is equal to v naught t minus half gt square. G is negative, because of that is a minus half gt square. Third equation, v square is equal to v naught square minus 2gh. And these are the equation of motion for a body which is thrown vertically up.
Next we'll see what is the relative velocity. The velocity of one moving object with respect to another is called relative velocity. For example, as in figure, a person in a boat is measure this velocity of a person in a parajet, and both objects are moving. Then what is the velocity of one object with respect to another is called relative velocity. That is called relative velocity. And like that, here is given, for example, two bodies A and B is moving with the average velocity VA and VB respectively. Then what is the velocity of A with respect to B, or velocity of B with respect to A? That is giving relative velocity. Let us take the velocity of B. That is a person in a bike is moving, and so that its velocity is measured by a person in a car A. Then what is the velocity of B with respect to A is given VBA, that is VB minus VA. Similarly, a person in a bike is measure a velocity of a person in a car, there is a velocity of A with respect to B, and it is given VAB, there is a VA minus VB. This is a relative velocity in that. Okay.
Let us say in case of two trains moving in a parallel track, then what is the velocity of one train with respect to another? If both trains are moving in a same velocity, then we experience that the one train is another train with respect to another train, it is not moving. Okay, ನಮಗೆ ಎರಡು ಪ್ಯಾರಲಲ್ ಟ್ರ್ಯಾಕಲ್ಲಿ ಒಂದೇ ವೇಗದಲ್ಲಿ ಎರಡು ಟ್ರೈನ್ ಚಲಿಸ್ತಾ ಇದ್ದರೆ ಆಗ ನಮಗೆ ನೋಡುವಾಗ ಇನ್ನೊಂದು ಟ್ರೈನ್ ಮೂವ್ ಆಗೋದಾಗೆ ರೆಸ್ಟಲ್ಲಿರುವಾಗ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ್ಯಾಟ್ ರೀಸನ್, ಸಿನ್ಸ್ ಬೋತ್ ಆರ್ ಮೂವಿಂಗ್ ಇನ್ ಎ ಸೇಮ್ ವೆಲಾಸಿಟಿ, VA minus VB is 0, the relative velocity of one train with respect to another becomes 0. Because of that reason we experience. This is a concept of relative velocity. Next, we'll derive expression for relative velocity using these objects. Consider two objects A and B as in figure moving along x-axis with a uniformly accelerated with the average velocity VA and VB respectively. Then its displacement from a origin and time t is equal to 0 is xa0, and displacement of body B from origin when time t is equal to 0 is xb0 as in figure.
Next, after a time t seconds, suppose it is displaced for a distance xat from origin and b is displaced for a distance xbt from origin, such that xat and xbt are displacement from origin after a t seconds. Then what is a velocity? Velocity means it is a change in position divided by time based on this velocity of A, that is a xat minus xa0 divided by t, and velocity of B vb, that is xbt minus xb0 divided by t. Then what is a displacement? I can write change in displacement xat minus xbt, that is equal to, from these relations, what is the t in denominator will take to this side, then vat, and also another equation t is denominator take to this left hand side, then vbt, and using these relations clearing this and write xa0 minus xb0 plus vat minus vbt. Next I'll once again rearrange it, then you'll get t is common outside the bracket, then xa0 minus xb0 plus va minus vb into t. But write is equation 1. Next we got what is xat minus xbt, that is xa0 minus xb0 plus va minus vb into t. Now change in displacement between two bodies in a time t, that I write as xat minus xbt minus xa0 minus xb0, and xat minus xbt now already derived from equation 1, that you will substitute here, then xa0 minus xb0 plus va minus vb into t minus xa0 minus xb0, and this is from equations, what is the minus sign outside the bracket is taken inside, then it is become minus xa0 and plus xb0. Then what is the plus xb0 and minus xb0 cancel, and again here plus xa0 and minus xa0 is cancels, then what is left here, va minus vb t. Then we know that from definition, the relative velocity of A with respect to B is change in displacement divided by time. This VAB is equal to VA minus VB into T divided by T. Then T and T are get cancelled. We'll get VAB, that is VA minus VB. And similarly, we got relative velocity of B with respect to A also, VB A, that is VA B minus VA. This is a derivation of expression of relative velocity in this chapter. This is the end of this chapter.